continue the analyze down here. So, as we said, the first thing that you're going to actually do is going to be, what was the first thing that we're going to do?
Did we say check
Check the weather. The first thing that you're going to actually do is going to be checking the weather, right? So after we get the weather, why? Oops. Don't worry. Why?
So then check the currency.
No. What is the reason we get the weather?
To determine which runway to use.
To determine which runway is in use. Okay, cool. Now, after that, we're going to determine our position, right?
Yeah.
So for that, we're going to go direct on the GPS. In this case, it's going to be direct to Tamiami. Okay. And let's say that today we are coming from this area. So you're going this way. Okay. Now now that we know that we are northwest of Tamiami, northeast of Tamiami, and we are coming to the airport, okay, we can start briefing the approach and setting it up. So, first thing that you're going to check is the approach to be within date. Now you're going to jump into the header section. So, really important items down here is going to be, if you read the ILS or localizer of this runway landing, what do we have to do? We have to set the GPS on the CDI on VLOC mode. Okay, otherwise you won't be able to receive information from the localizer. Next thing that we're going to jump to is going to read the city, the airport, because this airport, if you can have the ILS on Opaloca, you can have the ILS on Fort Lauderdale, you can have the ILS on Miami International, you need to make sure you actually are setting up the approach for the correct destination airport.
Yeah.
And now, city, perfect. After that, we're going to go ahead and set up the localizer. This localizer has to be set up where?
And your VR.
On the nav1. Nav1 plus, after we do this, we're going to ident. Very good. So we need to ident to determine if the localizer antenna or the ground station is actually working. After that, we're going to set up our approach course. Where we have to set up this approach course? Same thing, on the nav1. Exactly, on the nav1 receiver, which is the VOR number 1. Correct?
Yeah.
And then, we're going to read, we have runway length is 6,000 down here. Why do we have to know this one? Because we need to take in consideration our landing distance. Correct?
Yeah.
And then, touchdown zone elevation and the airport elevation as well. Why do we have to take in consideration the touchdown zone elevation one more time? Because of one regulation. This regulation is the 175, which says taking off and landing under IFR. And for landing IFR, remember, you gotta be in a good position that allows you to descend using normal maneuvers. The visibility prescribed on the approach plate has to be at or above the visibility at the approach plate. And then you can go down up to 100 feet over the threshold or touchdown zone elevation if you have the sidebars or red terminator bars inside. And then you can continue to land to the field elevation if you have one of the 11 items. Okay? After that, we have done this. Now, next thing to read is actually going to be for us the pilot briefing box. This one. Okay, cool. So what do we have right now? It's going to be super easy. Let me put another color down here. So this T down here, what does this T mean?
Have ODP procedures or
there's an obstacle departure procedure proposed for that airport or non-standard takeoff minimums. And this A down here is non-standard alternate minimums, okay? Now, these notes are going to normally, as I said before, they're going to be telling you what to do actually if the altimeter setting is not going to be getting it from Tamiami. Let's say, circle runway 13 right now is not authorized at night. That's the first note that they give you, okay? And next to that, it says, when local altimeter setting is not received, use Miami International altimeter setting, and what you actually have to do is increase the ILS on the right, category C and D visibility, and circling category D visibility 1 quarter mile. So if we're doing the ALS with altimeter setting for categories D, C, and D airplanes, you're going to increase these minimums. And as well, if you're doing what was it? Circling approach, you're going to increase this 1 statomile. You're going to increase that to category D. It's a category D. Instead of having 2 statomiles, you're going to have 2 1/4 statomiles of visibility. So that is actually what is going to be affect how the weather or the altimeter setting is going to be affecting your approach. Next thing that we're going to read is going to be the type of approach lighting system that we have. This type of approach lighting system has a special characteristic. First, what MALSR stands for? Remember?
Medium intensity runway lighting system.
Medium intensity approach lighting system with rail. That's what the R at the end is. So if we take a closer look to the approach system, we have center landing down here. Okay, we have a couple of 1,000 foot bars, and we have the rail at the end. Does this actually has red terminator bars or has sidebars? No, right? So that part of the regulation that we spoke about the touchdown zone elevation is no longer applicable on here because we do not have those equipments in here. You have two different types of symbols. These ones, okay, the alpha 5. What we have to focus on that one pretty much is going to be it is black. It's like a black background, or it is just transparent. Okay. Like for example, on here, this papillite is transparent. This one is bold. You can say black. What's the difference? What's the difference? This one is pilot controlled. When they have a black background, it means that it's pilot controlled. So what does it mean pretty much? That at the end of the day, when the tower of Miami Tower closes, you are actually capable to control that from their TTAF, which is 118.9 at night. Okay? So remember, 3,
5, and 7.
3, 5, and 7. 3 times for low intensity, 5 times for medium intensity, 7 times for high intensity. Now, next thing to read in here is going to actually be the misapproach procedure. The misapproach procedure that says climb to 2000. So remember, on the plan view, everything that is dashed is part of your misapproach procedure. So that is your misapproach segment. Climb to 2000. So we're going to climb to 2000. Then we're going to turn left. So based on this chart, we can expect to be at 2,000 feet around in here because from this moment everything's turning to the left. Left heading 088. So in here I gotta go 088 and intersect the radial 130 from Dolphin, which is going to be that one. 130 from Dolphin. So you're intersecting it around in here, and obviously it's going to be this radial because it doesn't say you're probably going to be here. Yeah, you gotta fly that outbound because you gotta go to Lovely, and Lovely is actually at 14.1. So you gotta determine that because if you intersect this radial, let's say like for example you didn't intersect the radial here because of winds and you're at 10 miles, obviously you gotta go outbound. But if you intersect this radial down here, like maybe down here, and you are at 15 miles, obviously this case is going to be flying the radial inbound. So it's going to depend on how far you are from the station.
Wait, where is
okay?
Where is this point here?
This point down here, what this box means in here is going to be the description of you actually misapproach procedure. So all this box down here. So what does it say here is that somewhere around the radial 130 you're going to intersect the you see that this one is broken, right? I mean, it does not extend more. Yeah. So they publish that over here on the side. So this one is actually how the holding looks like whenever you actually intersect the 130 radial. Do you understand me?
Yeah.
So you intersect the 130 radial, which is going to be some point in here, which might be some point in here. And then you gotta fly that until you reach the 14.1 DME and hold. okay, which for obvious reasons you're using a VOR is going to be a teardrop entry down here, okay, and you just keep holding and holding and holding until you receive a new clearance. You have two actual ways to identify lovely in this case. The first way is going to be Virginia key frequency, radial 175, or using a DMA distance of 14.1 DMA. Cool? Any other question?
No.
So, okay, so far we have determined misapproach procedure. Now, where else we're going to find this misapproach procedure, like in few words, is going to be, once you go to the plan view section, you're going to have it over here. Because the first thing that you gotta do is climb to 2000, right? So the first thing that you're going to do is you're going to climb to 2000, then you're going to left turn heading 088, which is the second thing, intersect the 310 radial, and hold on loop. For detailed information, you gotta visit this one, and you gotta read this one as well.
Okay.
Okay? So the misapproach procedure actually is going to be prescribed in 3 different parts of it. That's what, it's really important you to read that. Now, next item to read is going to be this one, which is going to be the communication box. The communication box. This bolt area, this box that is actually bold than the other ones, okay? What happens down here is that is the primary frequency for this approach.
Okay.
But who is going to be in charge of giving you the clearance, giving you vectors around, and tell you what to do to take you to the airport? It's going to be the approach control, which is in here. So the first frequency, your communication one, let's say for example in here, I should have 125.5 on the top on active, because I have to talk to these guys so I can request to them, and then I gotta have 118.9 on the standby. Why that on the standby? Because that's the next frequency that I'm going to use. And if you want to set up this one, the ground control and the clearance delivery, and they come too, feel free to do that. But once you're on the ground, you have time to fix it. The thing is, priority has to be done to the approach control and to the Tamiami tower. So let me raise this pretty quick. Cool. Any questions so far? No? Okay. That area, this area down here, what is it? Do you remember the name?
The plan view.
This area down here is called
The plan view.
plan view. Very good. This area down here is a plan view. So, what do you understand for a plan view?
It's like it's a view from above.
You're looking yourself from the top. So, we have determined, oh look, my little airplane is down here where Tamiami, but let's simulate we're coming on this area, right? So we are flying in here. We had determined that this is the north, this is the east, we are northwest of the airport. Let's say that we are 10 miles northeast of the airport. There are two different ways to approach an airport, okay? Remember, transition routes down here is going to be determined by whatever takes you to the initial approach fix. So, we know that we are here, but we need to now learn and we need to actually pay attention to where's the closest initial approach fix that we can expect to go. We can expect to go to Leiden, is one initial approach fix, and then as you can tell, there's no more initial approach fixes down here. So this is the only one. So whatever these guys gave me is going to be going to Leiden. But when we can expect them to give me they can take me to Leiden is when we're going to do a full approach. There's a difference between a full approach and a straight in approach. Why? The full approach requires you to go to Leiden, cross Leiden. In this case, you're going to fly outbound on the localizer on the 273 course, because the localizer only points to the east in this case, which means that you have reverse sensing down here, okay, and there's no way you can fix it. You're going to turn to the right, heading 318, and then you're going to turn to the left, 138 to re-intersect the localizer inbound. The straight-in approach instead will tell you from your position, these guys are going to give you vectors around so you can go and join the final approach course directly. No need of procedure change because all this red line down here is called a course reversal, a full approach procedure. Straight-in means that there's no need to do a course reversal or a procedure turn to align yourself with the final approach course that you have down here. So far, any question?
No.
Okay. Nothing, right? So that's the plan view. That's what I have to planify my actions so I can actually know what to expect. Next thing to read, because right now I don't know if, for example, they clear me for the ILS localizer runway 9 right approach of Tamiami, and they tell me November 172 Romeo Bravo, you're clear for the full approach ILS localizer. That means that I have to cross Leiden, do the course reversal, and then come back inbound and start descending. The thing is, at what altitude should I be the moment I cross Leiden? That's something that the profile view, which is this one, is going to give to you. Down here, we have Leiden.
Yeah.
And down here, as you can see, as well is going to be Leiden.
Yeah.
This whole line down here is where Leiden is placed at. But there's an interesting thing in here. The altitudes. So, if I am coming on a 273 course, which means that I am going to be going this way, okay, probably doing the course reversal, I need to cross Leiden at or above 2005. Why do I know it has to be at or above? When an altitude has an underline like this, means that you have minus 0 feet, but you have a tolerance of plus 100 feet from that altitude. If your altitude has 2500 on the top, a line on the top, you have tolerance of plus 0 feet, minus 100. If your altitude has double power or has a parallel line, means that you have a tolerance of plus 0 and minus 0 feet. You have to, and your mass remain on 2500. And if it has nothing, no lines, it's plus 100 minus 100. Okay? So that's pretty much what you gotta do. So, because we're doing the full approach down here, we have determined that because of our position is northeast of the airport and we're going to do the course reversal, we need to initially cross our initial approach fix called Leiden. Okay, again, you know that Leiden is initial approach fix because this couple of things, okay, that says IAF at 2,500 feet or at or above 2,500 feet. Then you start descending on the 273 outbound course until what altitude? At or above 2,000. Until when should I keep my 2,000? Let's look on the plan view again. We go down here, we fly for 2 minutes, okay? And why for 2 minutes, Gilbert? Is because there is a note on the profile view that actually says that you must remain within 10 nautical miles. But from where? From Leiden. And because we are not using DME in this case, let's say that we're flying at 100 nautical miles per hour. Okay? Let's say that, okay. How long is going to take me to travel 10 nautical miles?
2 minutes.
Huh?
Would be 2 minutes.
Okay. So, what?
Right?
No. It's going to be 6 minutes. Right? Because if you cover 60, it would do this 600 divided by 100 is 6. So it's 6 minutes. Right? So it's going to take me 6 minutes to cover 10 nautical miles. Which means that if I fly 6 minutes, I'm going to reach my limit. So, to protect myself, I'm going to be flying 2 minutes, then 1 minute outbound on the 3118, and then turn left, and I forget about the time because I did already the half of it. So I'm going to be halfway when I re-intersect Leiden. So I'm going to keep 2,000 feet until the point I re-intersect my localizer, but in this time it's going to be to the station. Now I'm going to be on the 093 course. The point of intersection, which is going to be pretty much my intermediate fix on this approach, I can start descending from 2000 down to 1500 feet. Now, when can I start descending from this altitude or from this altitude down here? You have to comply with two main things. The first thing that you're going to comply with is going to be, you need to be established, okay? And you need to be established on a segment, on an approach, which means you can be on the transition segment, you can be on the initial segment, you can be on the intermediate segment, which is down here, you can be on the final segment, you name it, any approach segment. And second, you need to be clear to execute the approach. Okay? You need to be established and you need to be clear for the approach so you can start descending from your altitudes. And finally, we're going to reach from 2000 on the 390 course inbound to the final approach fix. Why do we call the final approach fix? Because it is always going to be there, okay? Later on, we're going to learn what is a final approach point. But for now, this is going to be your final approach fix. Actually, for this approach, we're going to find ourselves with two different final approach fixes, okay? The first one is going to be this little cross that we call it the Maltese cross. The Maltese cross identifies your final approach fix for non-precision approaches. What are types of non-precision approaches on this one? Is going to be everything that does not have a vertical guidance. In this case, localizer or circling are going to be my non-precision approaches. So how do I identify this when I do not have a vertical guidance? Is whenever I recross Leiden intersection at 1500 feet. The moment I am on Leiden intersection again, I'm going to be at 1500 feet. And question, how do I know then when I am on Leiden then? There are certain approaches that they use VME to do this. They might tell you Leiden is located this far from the runway, this far from the localizer, but in this case I don't see any description of VME. But I see a radial that is a non-flyable radial because it has no altitudes, like for example this one, that has no distance, because this one actually is going to be a feeder route, a transition route, or a transition segment. But this one is a non-flyable radial with the only purpose of identifying a fix. In this case, it's going to be Leiden. So, where should I put this dolphin board tag radial 229er? This one is going to be under navigation number 2 and VOR number 2 if you're equipped with that. Okay? You can request assistance sometime as well, or you can use the GPS, but it's not recommended as well, because obviously this is an ILS approach. Okay? Other stuff to do is, that's the first way to actually identify the final approach fix. What else? This arrow, or you can say a bolt, or well, whatever it is for you, indicates the glass slope intersection altitude. What this means if your VOR looks like this, the CDI, which is on the middle, will be for the localizer, with a localizer. But now we have another one on the middle, which is the first time we're going to learn how to use it, and this one is called a glass loop. So what is a glass loop? If you go ahead on the papis, you read on the papis, you take a look on the papis will show you 2 red and it will show you 2 white when you are on the glide pad. This one will give you the same thing, will give you the 2 white to red, but on instrument conditions. Okay? How steep this angle of descent is going to be, that is something that you're going to encounter down here. The glide slope angle in this case is a 3-degree glide slope. Okay? And this TCH that we can find on the bottom is a threshold crossing height. What does this threshold crossing height means? It means that if you continue to follow the glide slope all the way around to the runway, from the runway to your airplane is going to be a 50 feet altitude the moment you cross up the threshold. If you continue to follow that. Why? Because legally, I mean, when you're following the glide slope is going to be somewhere around in here like a 1,000 feet. What it happens is, here's a couple of aiming points. The glide slope will give you guidance all the way so you can touch on the touchdown zone. Okay? So if you follow the glide slope between the runway and your airplane, it's going to be a separation of 50 feet. That is what a threshold crossing height is going to stand for. Okay? Any questions so far? No? So let me raise this, let me raise this, let me raise this. Okay, any question about this? No? Okay. So, when I'm going to be using this glass of intersection, which is going to be my final approach point for the ILS, okay, I already said it, it's going to be for the ILS, because this one is going to be the only approach that has vertical guidance. Okay, so remember, this glass of intersection is going to be for approaches that has vertical and lateral guidance. Okay, localizer provides you with lateral guidance, this one, but it does not have a glass loop to follow. That's what is non-precision. Circle in, well, then the circle in is just the approach that you're going to do, but you can choose between these two. You can either do the ILS or you can either do the localizer. Normally, because this one is a non-precision approach as well, you should use the localizer if you want to do a circle to land approach. Okay? Any questions so far? No? And now, to end with the description on the separation of the parts of the approach plate, you're going to encounter category, approach categories, okay? These ones. You have category A, category B, category C, category D. The categories of the approach is going to be, you can find them on the actually Bravo 2 page of the terminal procedure publication, okay? And what this means is you're going to be placed based on your speed. For example, if you're approaching from 0 to 90 knots, your approach speed, you're going to be on category A. And what is important to know our category, because category A approach minimums is going to apply for us. Next thing is 91 to 120 knots. We're going to find ourselves on category B. So as you can see down here, category A and B have the same minimums for the localizer. But it's different when you take a look on the category C and the category D. Category A and B have a status mile, and here you have this one. The minimums changed. Why? Obviously, you go faster, you will require more visibility.
Yeah.
Okay? So category C is going to start from 121 knots up to 140, and category D is going to be from 121 to 165. There's an extra one that is category E, which is everything that is over 165 knots of approach speed. How do I know which category referred to? That's something that we're going to be called a new V speed. You know that for the Cessna we have VX, VY, VR, you name it. Today, the part 97 of the FAR says the approach category is going to be called or going to be based on the VREF. And this VREF is going to be calculated, or it says pretty much that is published. You take whatever is published. Do we have a VREF on the Cessna 172? Have you ever heard about it? No, right, because it's not published. So how do I know what is my actually reference speed so I can determine in which category my airplane is going to enter? We're going to be multiplying 1.3 times your VSO. So if your VSO is 41, if you multiply that per 1.3, it's going to be around 56, 57 knots. Okay? It means that your approach speed should be 56 knots. Let's put as an example. Are you going to approach at 56 knots? It's super slow.
No.
But what we know so far is that because my VREF is 56, we need to keep ourselves within category A, which means that whatever approach speed you use has to be below 90 knots. That's why for protection, we're going to use 80 knots of approach speed. Okay? However, if, for example, you're in a hurry or you decided to go faster than this, now obviously, because you're not respecting or you're not keeping yourself within the range of category A, for some reason your approach speed reaches 100, let's say 100 knots on approach speed, now you gotta take category V minimums. Okay? Even though your VREF is going to be 50 something, you gotta take the category V minimums just because you were approaching too fast. Okay? Any question? No?
No.
So let me delete this one sec. Alright, let me throw this here. And now, one last thing. Alright, we were having the categories of the approach. Cool. Another thing is going to be okay. And then we have the minimums box. Okay. ILS, what type of approach the ILS is?
And that precision.
Precision, which means that has decision altitude. Every approach that has a vertical guidance will provide you with decision altitude. And the decision altitude today is going to be 210. And restrict back 112 when having started miles. What does this mean? This means that if you are descending on the approach, let me raise this pretty quick. Okay? You are descending on the approach from here. The moment you reach 210 feet, following the glass slope and following the localizer, you gotta take a decision. You either land or you go miss. You have no more options. You can see the runway environment, you have the visibility, you continue. You don't see the runway at altitude, you go miss. Nothing more, you don't even have to think about it. Is that clear?
Okay.
That's why it's called a decision altitude. You reach 210 and you either go miss or you land. That's all. And this is a clear example of an straight-in landing minimums. Why? This S down here says, if you follow the ILS with these minimums, this approach promises you that you will be having the runway in front of you, or at least within 30 degrees. You can do an straight-in. Because the other minimums, for example, these ones, they are not having an S, because this one does not take you straight to the runway. This one you got a circle to the runway. Let's say I want a circle to runway 13. I approach this one, but I got a circle to runway 13. Okay? Any questions so far?
So the minimum for here, like 210, is also your decision.
Is your decision altitude. But for non-precision approaches, even though this one has an S that says I will take you straight in land, this one is an straight landing minimums, the localizer just the localizer doesn't have a glass loop. Okay? So you're just following lateral guidance. This one, because it has no vertical guidance, can no longer provide you with the two right to red approach. So, it's a non-precision approach, which means that this one, instead of having DA, is going to be called MDA, or minimum descent altitude. Minimum descent altitude says, okay, you can go down from here, from the final approach fix, at a minimum of 500 feet per minute to a maximum of 1,000 feet. Between, we're going to take 700 for protection. As fast as you can, you're going to level up 460 feet until you reach either the runway or your misapproach point. A point at which you're actually going to go miss. On this one, the ILS gives me the altitude at which I gotta decide to go miss or not. This one just tells me the minimum altitude at which I can descend, but I can level off at 460 and continue that altitude until I reach my misapproach point or I reach the runway. So I can land. Okay? Alright. Any questions so far?
Wait, so you have to hold 460 until you hold the...
You reach the misapproach point. Now, where is this famous misapproach point? Sometimes they can appear that as a fix. They can, for example, if you have a GPS, they might tell you where this point is. But in this case, I don't see any radial, and especially this low altitude, Dolphin won't ever work. I don't see anything down here that says misapproach point. But guess what? You have a table for that. You have a table that tells you how fast you're going to be approaching, how much time it will take you to reach the misapproach point. As an example, we are approaching at 90 knots. From the final approach fix to the misapproach point that is somewhere around here, it will take me 3 minutes. What this tells me is, the moment I cross this guy Leighton and I start descending, I gotta start my time. So I can level over 460 feet for about 3 minutes. Okay? I mean, between the final approach fix and the misapproach point, it has to be 3 minutes. If those 3 minutes takes you down here and you don't see the runway, you go miss. If you do see the runway between, you just continue to land. Okay? That's what a misapproach point is. And it's based on this, guys.
So if you see the runway, you can just skip the misapproach point and continue to land?
Yes, because the minimum descent altitude is just allows you to go down, but not that much, so you can be able to look for the approach lighting system, to the runway lights or something that you need, so you can descend. Okay? But if you don't see anything, you will go miss at 3 minutes.
And at 460 feet.
And at 460 feet. You're not allowed to go down this way.
If you don't see any of the lights.
If you don't see anything, you keep to 460 feet, and if you reach 3 minutes, you have nothing inside, you just go miss. Don't think twice. Okay, it's unsafe. Okay? And for last, we're going to have the circling minimums. These ones as well are going to be a minimum descent altitude, which means you gotta keep this one, okay? Same amount of time, 3 minutes. But let's say that you have the runway in sight. The circle to length is going to as well be depending on which category you are at. Why? The category A circle to land minimums, it says from the runway that you're landing, you gotta remain within 1.3 nautical miles the whole time. You gotta start the circling, or you can join the traffic pattern within 1.3. You can do it of 0.1, 0.2, 0. You name it, but not at 1.4, because it's within, it's at or below. You understand that?
Yeah.
So category A approach, you're gonna remain yourself on within 0.3. Category B is going to be 1.5. Category C is going to be 1.7. Category D is going to be 2.3, and finally category E is going to be 4.5. So within 4.5 nautical miles of the runway, you gotta start your circling, which means you're approaching to the airport. Your DMA distance from the localizer in this case is going to reach, and the runway, I'm sorry, is going to reach 1.3 nautical miles. You can start circling, and you gotta make sure you remain at 1.3 and at your 460. Until when? Until you are aligned with final. You cannot descend from your minimums if you're not in a good position to descend. So you gotta keep yourself on everything until you actually reach on final from the runway that you are actually landing today. And to go miss from this one, let's say that for some reason there's fog all over this runway, what you gotta do is, you gotta make sure you follow the same instructions, climb to 2000, but you gotta line yourself with the runway that you were, or the runway that the approach was designated or built for. So if you were approaching on 9 and right, to circle 213, you gotta go back to 9 and right, and then from 9 and right, you gotta go ahead and proceed miss. Is that clear? Okay. So that is pretty much the description of an approach play down here. In this case, we have evaluated the ILS runway 90 right of Miami in detail. Okay? So, as a briefing, remember, the first thing we do is going to be listening to the aids, because we need to determine if the runway 90 is going to be in use or not. Maybe the localizer is out of service and we cannot use this one. Then our position, and then approach our waiting dates. Okay, the approach is waiting dates down here. Now we jump to the ILS localizer lock. Okay, Miami Executive Airport, frequency set, event, approach course on the VR number 1, runway length and so on, and elevation. Okay, pilot information briefing, read that. We have a medium intensity approach lighting system with rails. It's pilot control at night. Okay, miss approach instruction, we read that already. Okay, now set up the frequencies: COM1 active, a COM1 standby. You can put these two in COM2 if you want to. Now, since we are down here, we can expect an straight-in approach either vectors to final, or we can expect the full approach down here on Leiden. So at Leiden, we're going to join at 2,500 feet, cross Leiden, flight 273 for 2 minutes. Then the course reversal is going to be a right turn heading 318, left turn heading 138, re-intersect the localizer, which is going to be my intermediate fix. From the intermediate fix, if we are clear and established, we're going to start descending to 1,500. If the Glasgow is operative and we're doing a straight-in approach ILS, we're going to take the Glasgow intersection at 1,500 feet, descend to my minimums, which is going to be 210. If not, we're going to use the localizer, cross Leiden at 1,500 feet, identifiable with a 229er, by the way. And my minimums, my miss approach point is going to be placed at 90. If we approach at 90 knots, 3 minutes. If we approach at 80 knots, obviously it's going to be 2 minutes, and if 60 minutes, then 30, like 4 minutes and 3 minutes, 4 minutes, 3 minutes, like 3 minutes and 30 seconds, somewhere around that. Okay? Because we're slower. Okay, we're going to take more time. Okay? Now, that's going to be my plan of action. How long did I take to read this approach? I take almost 1 minute. Okay? It's just that you need to read this at home, you need to study this at home, you need to come prepared to the class, and after you have evaluated this, practice. Go to an aircraft, a Cessna 172, whenever you have a time, and start reading. Okay, approach waiting day, approach course, blah blah blah, be locked, blah, 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 blah. Okay? Use a simulator, something that can help you out with the workload management. Okay?
Yeah.
This is going to be a lot for you the first time, but it's going to be getting better and better every time that you fly. Any question?
No.
So that's it. Oh. All right.